I'm Mike James, and I'm going to show you how to solve a problem using the calculator. Now we've got this function fx equals 10e to the power of kx plus 3, and part of the graph of the function is shown below. And the first part is to work out the value of k. So part A, it says given that f15 equals 3.49, find the value of k. So we need to replace f of x by 3.49, and we know x is 15, so I'm going to substitute into this equation, and we get this result here. 3.49 equals 10e to the 15k plus 3. We can subtract 3 from both sides, divide both sides by 10, and we get this expression here, 0.049 equals e to the power of 15k. Now at this stage you can actually use the calculator to work out k. I'm going to go into calculator mode, hit menu and go to algebra and hit numerical solve. So I'm going to enter the numbers into the end solve. So I've got 0.049 equals e to the power of 15k. Hit the right arrow button and comma k. Okay, there we are. There's the answer, minus 0.201062, and you can round that to 3 significant figures. So we go on to the next part of the question, but before we do that, I'm just going to replace k by that value in the function, so we have the function there. Now in the next part of the question they introduce a new function which is a quadratic, and we have to find the area between these two functions, fx and gx. So I've quickly sketched the quadratic function here. Now we can get the sketch from the calculator, so that would be your first step really. You'd want to graph these two functions. So let's do that, and we go into graph mode. So I'm going to enter the first function, which was 10 times e to the power of a minus 0.201 times x. Hit the right arrow button, don't forget the plus 3. Okay, I'm going to hit enter. You just see part of the graph there. Now I'm going to hit tab and enter the second function. So f2x, and this is going to be the quadratic, so it's minus x squared just move this over so I can see it, plus 12x minus 24. Okay, so move this back, and there's our two graphs. Now we need to adjust the scale a bit. We're only interested really in x and y values in this first quadrant, so we could go to menu, and I'm going to use Windows Zoom, and you could put Zoom quadrant 1, but I'm going to do Windows settings and change the x minimum value to -1. X maximum, I'm going to make that about 12. Tab down to y minimum, make that -1, and tab to y maximum, make that about 15. Click OK, and that's there we are. We have the two graphs showing quite clearly now. So I'll just move this out of the way, and we want to really find the two values of x where the graphs meet, because that will give us the limits in order to find the area and between these two curves when we integrate. So to find these points of intersection where the two graphs meet, I'm going to hit menu, analyze graph, intersection, and you'll see that you get a vertical dashed line, and you can move it to the left of the first point of intersection, press enter. You can use the arrow keys to move it. Then you drag it to the right of the point of intersection and hit enter again, and you can see there's your x value, 3.89536. Now you need to find the x value for the second point of intersection, so I'm going to repeat this, hit menu, go to analyze graph intersection, and move the vertical line just to the left of the point of intersection for the lower bound, and then the upper bound, move it to the right, and I get 8.69405. So these two values of x will be the two limits for the integral, because remember, to find the area under the curve you have to integrate. Now because we're finding the area between the two curves, we will take the upper curve, which is the quadratic, and subtract the equation of the lower curve to get the area between the curves. So that's what I'm going to do next, and I've done this at this stage. I've put area equals, there are my two limits which I rounded to 3 significant figures, and there's the upper curve, which was the quadratic, minus the lower curve, which was the exponential curve. Now notice I put brackets in here. They're very important, because without those you won't get the correct answer. Now I've just tidied this up slightly. I'm collecting terms basically. Minus x squared I've left, plus 12x, minus 24, take away 3 is minus 27, so that can simplify a bit, and then I've put the minus 10e to the minus 0.201x in. Now you could integrate each of these terms individually, it's not that difficult, but then you still have the problem of substituting these values in, and it would be very time consuming, and you have the calculator, so at this stage definitely use the calculator to do all the work. Don't try and integrate, it's not worth it, because even then you've got to substitute these values in to the values of x, and it would be very difficult. So I'm going to go to the calculator and simply enter this into the calculator, let it do the work. So I'm going to go back to the calculator page, hit menu, I'm going to go for calculus and integral, and there it is. We just basically copy our integral in now, so you can see it's going to be the limits 3.9 at the bottom, so I'll put that one in, and up arrow, put the upper limit in, 8.69. Okay, now I have to copy minus x squared, so I've got minus x squared plus 12x minus 27, I can just see it now down here, minus x squared plus 12x minus 27. It's probably worth putting the multiplication sign between these things, so I'm going to hit the multiply sign, otherwise you may not get an answer. Minus 27, and I've then got minus 10 times e to the power of, so there's e to the power of minus 0.201. Again, I'm going to hit the multiply sign times x, and finally go to the dx bit and put an x in. So let's hope it works. Press enter, and there it is, 19.4913. So we round that to 3 significant figures, you get 19.5. And that agrees with the answer down here. So that is how to use the calculator to work out an integral or an area between two curves.